Hi, I'm Ms. Wu. Let's do some expanding of a plus b to the power of n. Here we have something familiar. A plus b squared is equal to a squared plus 2ab plus b squared. This is a quadratic. We're going to have a look at a plus b cubed. How will we do that? Well, a plus b cubed is the same as a plus b times a plus b times a plus b. But we know that second two lots is equal to that. So we can sub that in. And now we expand a times all of that and b times all of that. So a times a squared is a cubed. A times 2ab is 2a squared b. A times b squared is ab squared. B times a squared is ba squared. B times 2ab is 2ab squared. And b times b squared is b cubed. It's getting very tricky, there's so many terms. Let's neaten it up a bit. So we have a cubed, and we can see that there's a squared b there and a squared b there. So there's 2 plus 1 is 3. And we can see ab squared here and 2ab squared there. So there's 3 of those. And then b cubed over there. Notice the way we're writing it out. So a cubed and then a squared, 1a, no a. And the b cubed is backwards. B cubed, b squared, 1b, no b. So here is a general formula. And here is the general formula for a plus b to the power of 4. I wonder if you can see a pattern. Let me put them next to each other, and let's put the linear one as well, and let's see if you can find any pattern. So let's see, we put a and then no a to the power of 2, a to the power of 1, no a to the power of 3, a to the power of 2, a to the power of 1, no a, and again a to the power of 4, a to the power of 3, a to the power of 2, 1a, and no a. Let's see if you can see a pattern aside from the a and the b's. What about the numbers? Here we have 1 and 1. Here we have 1, 2, 1. Here we have 1, 3, 3, 1. And see this pattern here. Can you see what's happening here? So the two numbers on top add up to be the number at the bottom. So if we look at it, we're going to have 1 here, and then 1 plus 3 is 4, which is right there. And then 3 plus 3 is 6, which is right there. And then 3 plus 1 is 4, and then 1 over there. So we can use that to predict the next line. So it will be 1, 5, 10, 6 plus 4 is 10, 4 plus 1 is 5, and 1. So we can write all those numbers out. And then we can write out our highest power of a. So a to the 5 will be having coefficient 1. The next thing will be plus 5, a to the power of 1 less than that, 4, and then we start writing b. Then the next one will be 10, and then this time a to the power of 3, and b will be squared. So the power of b is going up by 1, the power of a is going down by 1, and the coefficient is right there. Let's see if we can figure out the next term. So again, it's a 10, a squared, and b 1. Sorry, b 3. Even I'm getting mixed up. Be very careful. And you can always check b1, b2, b3. The next one will be b4, a5, a4, a3, a2. The next one will be a1, and the coefficient is 5. 5a, b4. And the last one is coefficient of 1. There's no a, and it's b to the power of 5. This is called Pascal's triangle, and we use it to expand all our polynomials. Example 1. So to come up with this formula, you would write your Pascal triangle really quickly on the side. We want 4, so we write until we see the 4. So 1, 1 add up to 2, 1, 2 adds up to 3, 1, 3 adds up to 4. So you write until you get that to that line, and you write 1, 4, 6, 4, 1, and you write a to the 4, a to the 3, a to the 2, a to the 1, and you write b squared, b3, b4. And you write this out, and then you'll substitute x for all the a's and 2y for all the b's. So we have x to the power 4. Now we have 4 times x to the power 3 times b, which is 2y. Now we're going to substitute that part. So plus 6 x squared times 2y squared. Now we're going to substitute plus 4 times x times 2y to the power of 3. And then the last term is b to the 4. So 2y in brackets to the power of 4. Make sure you use brackets, otherwise you might forget the power of the pronumeral. Now let's expand that. So x to the 4, 4 times 2 is 8, x cubed y. 6 times 2 squared is 4, 4 times 6 is 24. And then 2 cubed is 8 times 4 is 32. And then 2 to the power of 4 is 16. Double check you don't have to add anything, there's no like terms, then you've done it correct. Let's do one more example, this time with a 6. Here we have the next line, so then we need the line with a 6. So 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, etc. Pause the video and unpause, and I'll leave the solutions here for you to work it out. Example 3, 5x minus y cubed. So for cube we have 1, 3, 3, 1. Try and figure out where the numbers go. So 1, 5x cubed, don't forget to use brackets so you don't forget to cube the 5. The next term is 3 times 5x squared times minus y. Remember the a, or the first term, is cubed and then it's squared, and the next bit it will be to the power of 1, like that. And then don't forget the 3 and then minus y squared. And the last term has no coefficient, or coefficient of 1, sorry. And then minus y to the power of 3. So it's a cubed plus 3a squared b plus 3ab squared plus b cubed. Or you can check it by looking at the first term, and it's cubed, squared, single power, non-existent. And then 1, 3, 3, 1. And for the minus y, it should be none, 1 squared to the power of 3. Let's expand. So 5 cubed is 5, 25, 125. X cubed plus 5 squared is 25 times 3 is 75 times minus y becomes negative. And then we have 3 times 5 is 15 times minus is still positive. And then minus y cubed, an odd power, is negative. That's it for me today. I'll see you next time. Bye.